What if I told you that you could build a RAG system that actually understands your documents like a human would? Not just throwing embedding at vector database and hoping for the best, but intelligently navigating through the content the way you would when researching a topic. Hey everyone, today I'm going to show you an advanced RAG system I built in .NET that uses hierarchical exploration and agent-based search to handle massive documents. We are talking about 100K words, complex technical manuals, and it can answer any questions with actual precision. Stick around because I'll show you the architecture, the code, and why this approach destroys traditional vector RAG system. Let's start with why traditional RAG systems suck. So, you know the drill, chunk your document, create embedding, stuff everything into a vector database, and pray that semantic similarity find the right content, right? But here is what happens in reality. So, like you ask, how do I implement JWT authentications? And you get back some random paragraph about security principles, right? So the information gets lost in the embedding compressions. Long natural questions get lost by fuzzy matching, and complex multi-part questions, forget about it. Traditional RAG systems treat document like a bag of random chunks, right? But humans don't read documents that way. So when you are looking for information, you first find the relevant chapter, then drill down to specific sections, extract the information, right? The exact information we are looking for, and then we synthesize from multiple sources. So that's how we do in real life, and that's exactly what we are going to build today. Here is our intelligent RAG system architecture. We have 5 core services working together. The first one is document processor. This service is not just about text extraction. It intelligently parses PDFs, detects headers, builds hierarchical relationships, and preserves document structure. Think of it as creating a smart table of contents with parent-child relationships. The next one is hierarchical explorer. This is our human-like navigation system. It finds relevant chapter first and then drill down to sections and then extract precise content, just like you would. The next one is content discovery agent. For complex questions, this creates a strategic search plan. It might say, first look into the direct answers and then find supporting examples and then creating the related concepts. The fourth one is Olama service or LLM integration layer, right? But we are not just throwing prompt at it. We use structured analysis for questions complexity and then content relevance scoring and then intelligent synthesis. So that's how it will be used. And the final one is intelligent RAG system, the orchestrator that decides which approach to use and combine results, right? Because we have multiple choices here, like whenever you would ask a question, then this intelligent RAG system class or service will then determine which approach to use. So the magic happens in the flow. First, the question comes in, we analyze complexity, choose hierarchical or agent-based approach, right? And then if that fails, comprehensive fallback search, intelligent synthesis, and source attribution. Let me show you some key code. Here is our document processor. So this is where the magic starts. We have a process PDF async method that extracts sections, builds hierarchy, and optimizes the structure. But look at this extract section async method. We are not just splitting text, right? We are detecting header levels using regex patterns, numbering schemes, and even content analysis. So our detect header level method looks for numbered headers like 1.2.3 headers, all caps headers, and intelligent content detection. So this creates a real document hierarchy that preserves the structure. Now, here is where it gets interesting. Our hierarchical explorer doesn't just do keyword matching. We use the LLM as an intelligent content analyzer. not just a pattern matcher. So it understands the context, extracts specific requirements, and score relevance. Look at our extract detailed content async method. We send structured prompt asking for relevance score, extracted content, and relevance region. So the LLM analyzes the content and tells us exactly how relevant each section is and why. And here is our enhanced synthesis. So we group findings by relevance, right? So high relevance content gets priority, medium relevance provides supporting context, and then we build comprehensive answers with primary sources, supporting sources, and related information. So that's how we do it. But the real intelligence is in our fallback system. When hierarchical system fails, we don't just give up. Our use comprehensive search fallback method searches all 193 sections with intelligent pre-filtering. It's like having a search assistant that never gives up. This comprehensive search uses calculate basic relevance score to quickly filter sections, then applies the same detailed analysis to the most promising candidates. We are talking about processing thousands of words in seconds to find exactly what you are looking for. Now let's see this in action. I got a sample PDF loaded and let's ask in the same question that was failing before. What are the requirements to implement KFast? I'll run our comprehensive search command and watch this. Look at that. The system is now finding multiple relevant sections. It's not just grabbing random text, right? It intelligently identifying content about KFast requirement from different part of the documents. So here is what it found. Implementation requirements, technical specification, and even related configuration details. Notice how it's providing context from multiple sections and giving us a relevance score for each piece of information. Let me try another question. How do I configure the security settings? Again, comprehensive results, the pulling from security related section, configuration chapter, and even troubleshooting notes, the system is thinking like a human searcher and gathering all information before synthesizing an answer. This is the difference between a basic RAG system and an intelligent one. We went from I don't have enough information to detailed multi-source answers that actually help users accomplish their goals. And the best part, this entire process took just a few seconds, and the system learned the document structure once during processing and then reused that knowledge for every query. So, why does this approach work so much better than traditional RAG systems? First, precision, right? Instead of relying on vector similarity that might miss context, our system thinks like a human. It understands that when you ask about implementation details, you need to look in technical section, not in introductory overviews. Second, it handles massive documents smoothly. While vector-based systems struggle with 100K words documents, our hierarchical approach navigates them naturally. So just like you would flip through a book's table of contents, right? Third, no expensive infrastructure. So we don't need vector databases here, embedding models or complex similarity calculation. This runs on your local machine with just an LLM. And finally, the fallback system ensures that you never get no result found, right? If the intelligent navigation doesn't find what you need, the comprehensive search kicks in automatically. And the result? You get precise, contextual answers from large documents in seconds, not the hit or miss responses you get from traditional RAG systems. Let me share some impressive technical achievement of this system. Okay, so we are processing 2 MB PDF with 193 sections and approx like 10,000 words in just less than 20 seconds. So document processor intelligently detects headers using pattern recognition and build perfect hierarchical structure automatically from just one root chapter, right? So then the content discovery agent creates strategic search plans. It doesn't just search randomly, it actually plans where to look based on your questions type. Technical questions go to implementation section, conceptual question go to theory sections, and then our LLM integration uses structured prompt with relevance scoring. So instead of just returning raw text, every piece of content gets scored as high, medium, and low relevance, and then synthesized into coherent answers. The fallback system is brilliant. If hierarchical exploration fails, it automatically switches to comprehensive search across all 193 sections. So you get the best of both worlds. Intelligent navigation with complete coverage. So there you have it, a complete intelligent RAG system that actually works. Let me quickly recap what we have built together. We created a multi-layered system that goes beyond simple text chunking. Our hierarchical approach respects document structure. Our content discovery agent thinks strategically about search, and our comprehensive fallbacks ensures we never miss relevant information. So the results speak for themselves. Instead of getting generic response like I don't have enough information, our system now provides detailed contextual answers by intelligently analyzing and synthesizing content. Now, where can you take this further? Considering adding vector embedding for semantic similarity, implementing multi-document support, or intelligently or integrating with different LLM provider. You could also add caching for better performance or build a web interface for easier interaction. The complete source code is available in the description below. Feel free to clone it, experiment with it, and make it on your own. If you find this helpful, hit that subscribe button for more AI and .NET content. And here is a challenge for you. Try this system with your own documents and let me know in the comments what kind of result you get. I would love to see how you adapt and improve this approach. Thanks for watching and I will see you in the next video.